The world of embedded software is undergoing a seismic shift, driven by the powerful forces of artificial intelligence and supply chain transparency. But here's where it gets controversial. Are organizations truly prepared for what this means for software quality and security? Black Duck, a leading cybersecurity firm, has just released its eye-opening report, The State of Embedded Software Quality and Safety 2025, revealing striking insights about how AI is transforming this landscape. According to the report, a staggering 89% of developers and security professionals are now using AI assistants in their work, while an even larger 96% integrate open-source AI models into their projects. This widespread adoption highlights AI's critical role, but also raises questions about control and governance. Despite progress, weak governance remains a major concern. About 21% of respondents expressed uncertainty about their ability to halt vulnerabilities in their embedded software, and an alarming 18% admitted to shadow AI, using AI tools without organizational approval, a risky practice that many underestimate. The drive toward transparency is also evident, with 71% of organizations producing software bills of materials, SBOMs. Interestingly, this push is influenced more by pressure from customers and partners rather than regulatory compliance alone. Meanwhile, on the technical front, 80% of companies have embraced memory-safe programming languages. Notably, Python is overtaking traditional languages like C++ in certain embedded applications, signaling a shift in development preferences. What's particularly fascinating, and perhaps overlooked by many, is the contrast in project success perceptions. This optimism gap raises important questions about how business risks and technical challenges are communicated and managed. The report also exposes a critical flaw in relying solely on shift-left strategies, those focusing mainly on early-stage security efforts. With shadow AI creeping onto developers' desktops and the necessity for ongoing SBOM monitoring well after deployment, risk management must extend across the entire software development lifecycle. Organizations need to embrace a shift-everywhere approach to truly mitigate threats. Industry experts weighed in on these compelling findings, each adding valuable perspectives that deepen our understanding. Diana Kelly, Chief Information Security Officer at Noma Security, warns that AI systems, especially autonomous agentic tools, are vulnerable to manipulation. She explains that because AI interprets prompts as commands, a single poorly crafted or malicious prompt can wreak havoc, potentially wiping out entire systems. Kelly underscores the urgent need for strong AI governance to prevent attackers from exploiting these powerful agents, which can operate at massive scale and cause far more damage than traditional applications. Nicole Carignan, Senior VP of Security AI Strategy at Darktrace, emphasizes that AI governance must be built on solid data science foundations. She points out that AI's reliability hinges on the quality of its input data, making it essential for organizations to understand how data is sourced, classified, and secured. Carignan also highlights the shared security responsibility that comes with adopting third-party AI tools, akin to cloud security challenges, and stresses the importance of robust controls, clear access boundaries, and cross-functional collaboration involving legal, privacy, HR, and compliance teams. She cautions against static policies, advocating for dynamic, real-time governance as AI technologies continue to evolve. Guy Feinberg of Oasis Security draws an intriguing parallel between AI agents and human employees. Like humans, AI agents can be tricked by attackers using social engineering tactics, but organizations often fail to apply the same rigorous security controls to these non-human identities, NHIs. Feinberg argues that since manipulation of AI agents is inevitable, the focus should be on strict identity governance, limiting access, monitoring activities, and enforcing least privilege. This approach ensures that security teams have the visibility needed to detect and stop unauthorized actions before they escalate into breaches. Mayurish Dani, security research manager at Qualys, turns the spotlight on SBOMs in relation to government regulations. He advises organizations to proactively request SBOMs from vendors as the simplest risk management step. While more invasive techniques like firmware dumping exist, they risk violating agreements and should only be done with vendor consent. Dani also stresses the importance of auditing exposed network ports, mapping them to software components via SBOMs, and carefully reviewing OS update logs. Furthermore, he calls for stricter vetting and contributor verification for open-source projects. To defend against supply chain attacks, security leaders must invest in comprehensive visibility, continuous risk assessment, and proactive management of end-of-support software. Finally, Satyam Sinha, CEO of Acuvity, highlights the overwhelming complexity organizations face in addressing AI risks amidst a flood of regulations and rapidly evolving technology. Despite the challenges, he sees a silver lining in the growing role of generative AI, GenAI, across industries, from customer service to software development. Sinha advocates for embracing GenAI-native security solutions to amplify limited personnel resources. He believes that specialized training and certifications for cybersecurity teams will be critical in closing the confidence and capability gaps. According to him, the decisive factor to successfully managing AI-related risks will be the adoption of tailored AI-native tools combined with upskilling teams, because without this, the security challenges will only multiply. This report sparks substantial debate. Can organizations truly keep pace with the rapid AI-driven transformation of embedded software? Are current governance models sufficient, or do we need a fundamental overhaul emphasizing continuous oversight, cross-disciplinary collaboration, and AI-specific security protocols? How much are shadow AI practices undermining overall risk management? And can enterprises realistically police their developers' tool usage without stifling innovation? We'd love to hear your thoughts. Do you think AI's integration in embedded systems is more of a breakthrough or a ticking time bomb? How should businesses strike the balance between harnessing AI's potential and safeguarding their software environments? Share your views and join the conversation below.